recording here, and I want to finish up with the epithelium here, all right, in which we were talking about the transitional epithelium. This is that transforming epithelium. And this slide here is showing you, all right, the difference. You can see the little inlet diagram here of the empty bladder, and then you can see the inlet diagram here of the full bladder. And you can see how, all right, the cells appear, especially the apical cell layer, all right. Those cells will have kind of like a rounded top to them, okay, and they won't be compressed down. All right, the lower levels will be a little bit flatter because obviously there's cells on top of that. All right, but when we get to our full bladder here, when we look at the apical layers here, those cells are more flattened, all right, because they're being compressed, all right, by the urine in the bladder. You can see it almost looks very close to a squamous cell type of configuration. But when we get here, all right, to the empty bladder, all right, when it's relaxed, all right, we have these nice rounded tops here to the transitional epithelium. And then down here, all right, the lower cells look a little bit more what we call polyhagnal, all right, or almost kind of like a cuboidal, similar to a cuboidal shape. I wouldn't go so far as to calling it cuboidal, but it's similar to that. Again, it just depends. Oh, and then of course the binucleated cells. Let me zoom in a little bit more. That's the cell that has two nuclei. You can see a little bit better on some of these. Here's one right there. See that? You got these two dark staining dots inside the one cell here. All right, that's the binucleated cell. Here's a really good one over here. Okay, and this one here is circled too. You can see two dots. That's a really good one. Okay. Correct. There's two darkly stained dots inside the cell. All right, those are going to be the nuclei. For the most part, usually because the nuclei will stain darker because of the nucleic acids inside. Depends on the stains that they use for the slides, but they'll have that appearance there. Okay, so that should conclude, all right, epithelium. Simple rules here. You probably already know this, but in case you don't, if you want to write it down. All right, think of simple epithelium, okay? Three main functions for it is absorption, filtration, secretion. All right, it is not ideal, okay, for protection because it's so thin. It's a single layer. All right, and then when we talk about stratified epithelium, all right, it has a protective function. It's great for mechanical stresses. All right, the soles of your feet. That's what I always just remember. I always think of the soles of my feet. You know, I'm very thankful that they are stratified epithelium. Okay, and in fact, there's really thick version of stratified epithelium. And when we talk about thick versus thin skin, when we go over chapter 6, you'll be able to appreciate that a little bit more. It's just kind of a simple thing to remember here, right? Simple versus stratified epithelium. And I have to say, well, first of all, do you folks remember the 4 tissue types in the body? Well, you're thinking of the muscles. Yeah. 4 tissue types. Just, yep, nervous, and muscle, connective, and epithelial. Yep. My son is doing this material in his 7th grade class, and I actually quizzed him on it, and he actually knew. I was really proud. And so my class is probably getting tired of me that I keep asking them that, but if you have me for 211, I ask them the same thing because this stuff comes back. All right, you will be revisited by this type of tissue. Histology plays an important role because histology governs a lot of the physiology that you're going to be learning in this course. All right, so if you understand histology, I'm not saying expertly, okay, but if you understand it pretty well, a lot of the concepts will make more sense to you. Okay, that's the important thing. All right, we're gonna, since we are talking about epithelial tissue, I do want to talk about glandular tissue here just briefly. All right, we talked about the anatomy of it in lab class last week, but I do want to talk about the actual more of the physiology, all right, part of it. When we talk about glands, okay, we saw, all right, that glands can either be one individual cell, and we were talking about the goblet cells. Remember, it was one cell. It made mucin, okay, and it helped to make mucus when it mixed with water, all right. And then we will talk about the multicellular organs, all right, for glands. But you have to understand that glands are composed of epithelial tissue, okay? Epithelial tissue. And in fact, several of the glands, as you're developing as a baby and fetus and all that, all right, those glands will come, like your sweat glands are epithelial tissue that invaginates, it sinks down into the deeper layers of your skin, okay? So glands are going to make things, and then they're going to secrete them or emit them out, all right? We talked about mucin from our goblet cells. Chapter 17 next semester, you're going to talk about hormones, all right? Those come from the endocrine glands, but also enzymes, like your salivary glands, your pancreas, all right? They make digestive enzymes for things, okay? You have some stomach epithelial tissue that produces the digestive enzymes, all right? Electrolytes, very important. Your sweat glands will emit and secrete electrolytes. All right, that's why in those Gatorade commercials, they always say, you know, drink Gatorade to rehydrate, but also they're always pressing you about electrolytes, all right? You want to have those electrolytes, okay? So there's two types, endocrine and exocrine. All right, endocrine are going to be, it's very important that you know this, they do not have ducts, okay? So therefore, since they don't have a duct, much like your air conditioning system in your house, I talked about that before with the ducts, all right? These glands don't have that tubular system, so they have to secrete their hormones or whatever their product is into the bloodstream directly or into the interstitial tissue or fluid. And what is that? That is the tissue that's outside the cell or outside the gland, okay? So that's what we talk about when we talk about the interstitial fluid, all right? The interstitial fluid is the fluid that's kind of surrounds a lot of our tissues, all right, our cells and whatnot, all right? The exocrine glands, all right, they started as epithelium, but then they kind of pushed their way down, all right, into connective tissue. Perfect example is going to be the sweat glands of our skin, all right? They started off in the epidermis, which is epithelial tissue, and then they invaginated or pushed their way down into the dermis, okay? But they do have a duct, okay? So it's the exocrine glands we talked about in lab class, in which they had two components or two parts. They had the secretory portion, all right? That's when I drew that kind of rounded structure, and then it almost looked like I guess you would call it an Erlenmeyer flask if you've taken chemistry, all right? And then the rounded portion is the secretory portion, all right? We also call that the acini, and this makes all the stuff, all the whatever we're going to secrete, and then it gets pushed up into this skinnier portion, and that is the duct, all right? Or the conducting portion, okay? So several examples: sweat glands, mammary glands, and salivary glands. All right, we'll talk about some of those. All right, so surrounding the duct, all right, we'll have connective tissue all over here to help support the ducts. All right, so the first type of gland that we're going to talk about, we've seen it already, is the goblet cell, the unicellular exocrine gland. All right, it does not have a duct because if you remember the shape of it, remember you had this big kind of fat part here, then it gets skinny. All right, and then at the bottom of it, okay, we had the nucleus was sitting down here, okay, and then we'd have the opening right here. So it really doesn't have a duct. You had all these mucin molecules, different proteins here that would sit in here. It's a glycoprotein, all right, and then they would move out here to the surface of the epithelium, all right, depending on where we were. If it's the digestive tract, all right, it would be like the small intestine, all right, large intestine, all right, and then also in the respiratory tract we saw goblet cells, okay? So these types of cells, they don't have a duct, all right? That's because they are so close to the surface, all right, of the epithelium that they can emit their secretions right there, okay? All right, so the other type of exocrine glands that we're going to talk about are what we call the multicellular, okay? So this is the one that I just drew for you on the previous page, all right, in which you had, all right, that fat rounded area here, okay, the acini or the secretory portion, all right, then it's connected to the duct there. So this is the acini, looks like a grape, okay, so that's going to produce, that's going to make our secretions, all right, and then we have to transport the secretions to the epithelial surface, and we do that through the duct right here, okay? And so these types of glands will have a fibrous capsule on the outside. This is important because you'll see this again in 211. All right, but these fibrous capsules, one, they provide protection, obviously, but support. Right? Usually the fibrous capsule is made up of a dense, irregular connective tissue. Dense, irregular connective tissue it's pretty strong, okay? It can withstand multi-directional stresses on it, okay? But now with these capsules here, so here's your, I like to draw a lot, okay? So here's your gland here, let's say. You have this capsule, that blue is the capsule. What will happen, parts of that capsule will invaginate into the inside of the gland. And it creates small compartments, okay, inside here, okay? And we refer to those small compartments, all right, the part of the gland in those compartments as the lobes. I'll show you a way better picture. I don't know why I'm drawing that. Here's a way better picture, all right? So here's your exocrine gland right here, and this green part is that fibrous capsule. But you can notice that parts of the fibrous capsule have invaginated or pushed its way in. All right, and it makes these small little compartments here, or these sections. Okay, and those are called the lobes. All right, and if we look at one section, so we're going to now zoom in on this one area here, you can see, all right, these little red dots here, that's the acinus or the secretory portion. The acinus is the description. If I were to say, give me the anatomical description of that, you would say the acinus, all right? And then I'd say, well, what's the physiological function? Like, what does it do? It secretes. It's the secretory portion. That's what we're talking about here. All right, and then where it tapers down and becomes this tube-like structure, that's the duct. All right, and that's going to conduct or transport the secretions out to the epithelial surface. Okay, so remember now we're dealing with exocrine glands. Exocrine glands have ducts. Okay, and then you'll have a major duct, and that duct will then secrete whatever it is out into the epithelial surface there. All right, so we're going to mainly focus, because again, you're going to talk about endocrine glands in another class. Okay, so we're going to focus mainly on the exocrine glands. All right, and so there's three types, and you've already seen all three types here. All right, some of those words should look familiar to you. At least the top two should, merocrine and apocrine, because when we were labeling the skin, you have a merocrine gland and an apocrine gland. All right, the third one there is the classification, but we saw it as the sebaceous gland. Remember, the sebaceous gland was that lobulated gland that sat on top of the hair follicle. It produces the oil, which makes our hair greasy appearing if we haven't washed our hair in a while. All right, so the first one, we're going to go through each. I'm going to do one, and I'm going to show you a picture, and then I'll come back to the next description. So the first one is the merocrine gland. All right. So these glands, all right, the cells there of these glands are going to make their secretions. They're going to package them up, all right, into a vesicle. All right. It's like mailing a letter. All right. And then they're going to release that vesicle towards the plasma membrane. And if you remember through the process of exocytosis, we have a secretory vesicle, and it fuses with the plasma membrane, and then it releases its contents outside the cell. All right? So our salivary glands do this. Some of our sweat glands will do this. Okay? So let me show you a picture here. I'll come right back. All right, so here's the first one. Okay? Our merocrine gland. Here's our secretory portion, the acinus. And you can see we have our secretory vesicles inside, okay, with the secretions. And then they move and migrate towards the apical surface, the top portion here, and then they'll fuse with the plasma membrane through that process of exocytosis. And it releases the secretions out here into the lumen, and then they'll move into the duct, the conducting portion, and then out onto the epithelial surface here. Okay? So that is actually how you make saliva. Okay? And so the enzymes of saliva, all right, you'll have some liquid component to it, but then you'll have some enzymes, amylase and lipase, and those are enzymes to use to break down proteins and fats. Okay, all right. So that's the merocrine gland. That's the first type. Okay. So your tear ducts. Okay. The lacrimal glands there in your tear, which sits on the lateral side of the top of your eye. All right. They produce your tears through that process, all right, merocrine, okay? All right, the next, now some of you probably don't know what a lava lamp is. You might not be old enough, but I remember. I was wanting one for a kid, but my parents refused to let me have one because they said I was going to break the thing and all the chemicals were going to spill over the room. But that's really cool. All right. So a lava lamp or these types of glands, the apocrine glands now, they're a little bit destructive. All right. Not terribly, but a little bit. So what will happen in this situation, all right, the apical membrane is going to pinch off of these cells. The whole, I shouldn't say the whole, but a good portion of the apical membrane will pinch off and become the secretion. So these types of secretions are going to be a little bit more viscous, a little bit thicker, all right, than Merocrine glands, all right? I tell folks, if you think of Merocrine glands like the sweat glands on your arm, when it gets hot and you start to get sweat pouring down on your face and your arms get sweaty, those are Merocrine glands. That's more of the majority of the secretions from those types of glands are water, okay? These types, the apocrine glands, they're going to be a little bit thicker, okay? Ceruminous glands, that's the glands in your earwax, okay? Cerumen. All right, mammillary glands also. That's why milk is, no, not generally milk, but breast milk is a little bit thicker, not just because of the secretions of the milk, but there's a high fat content also. All right, but part of that comes from that apical membrane because remember, what is in our plasma membranes? Phospholipids. Okay, we also have some cholesterols and some proteins and whatnot. Okay, so if I show you a picture here, all right, of our apocrine gland, and think apocrine apical region of the cell, okay, gets pinched off. So if you look here closely, you can see, all right, how, all right, a big portion of the apical membrane just pinches off, okay? And then it moves into the lumen here, and then again travels up into the conducting portion here, okay? So we'll see, all right, this occur in the mammary glands, all right, the ceruminous glands, all right, in the ears, and then one of my favorites, the hyaline gland, okay? If someone describes, and I'm not talking about the Holocaust, but a Holocaust, again, another thing when I was growing up, they were talking during the Cold War, they talked about a nuclear Holocaust. Well, Holocausts are bad, destruction, things occur, all right, damage. Well, this gland is an all or nothing gland. It kills itself, all right? It literally ruptures. And it's that process of it rupturing then now has made it the secretion, okay? So this will be even a thicker type of secretion, all right? It'll be more viscous than the apocrine and merocrine glands, okay? And so this is going to produce an oil, all right? So we'll see this whole cell, and you can kind of appreciate it here in this picture when we talk about the hyaline gland cell here, the hyaline gland. You can see all these cells packed in, and then the cells in the apical portion, they just rupture. They disintegrate, they degrade, and then the whole cell itself becomes the secretion, okay? And then move into the conducting portion here. All right, and we see that in the sebaceous glands of our hair on our head, on our arms, wherever. All right, questions about that so far? Not too bad? Okay. Not incredibly exciting, but interesting nonetheless. All right, epithelial tissue done. Wash our hands. We got to move through connective tissue, all right? Connective tissue is a tough one, okay? Because it is a very diverse and it's the most abundant type of tissue in your body, okay? You're going to have a newfound appreciation of all the tissues, especially connective tissue, all right, as we move through this, okay? So we're going to see that this type of tissue in the body, all right, and when you know the types of when you know the types of connective tissue, it'll make sense. All right, like for example, all right, the first type of function for connective tissue is support. Well, one of the types of connective tissue is the skeleton. So doesn't that make sense? What's the skeleton do? Support your body. Okay, and it allows things to attach to so they can support themselves. All right. So we also have protect and bind organs. Skeleton does that also, all right? So we'll go through a lot of these connective tissues and the types, and it'll make sense. Tendons and ligaments, all right, support. They help attach to the bones to bone if you're a ligament, and then tendons attach muscle to bone. and in some cases to the skin, and in some cases to other muscles. Okay? Adipose tissue. Function. We learned about the functions of adipose tissue when we were talking about fat. All right? Energy storage, cushioning, insulation. All right? All important. So we'll move through all these, all right, and we'll talk about it. The last one here, blood, we won't talk about too much. Okay? That will be another class in 211. All right? So all of the connective tissue comes from the embryonic connective tissue called mesenchyme. You need to know that and memorize that one. You're going to see that again when we get to some other tissue types in later chapters. Okay? So when you see mesenchyme, think of embryonic connective tissue or an embryonic cell or something embryonic, right? Which means that this type of tissue can differentiate into almost any type of connective tissue that it feels like. All right? So when we talk about connective tissue, there's a big difference between connective tissue and epithelial tissue. Remember, epithelial tissue, and I asked this to my 211 class last night when I was going over the heart with them. We're learning the layers of the heart, all right? And we saw that in certain layers of the heart, if it was epithelial tissue, I asked them, is there any blood vessels in there? And they said no, which is good. They remembered that, all right? So epithelial tissue is avascular. Connective tissue is vascular, okay? And in some types of connective tissue, you'll have very little blood vessels. And in some, you'll have a lot. But it is vascularized. It will have blood vessels in there. But it just varies depending on which type of tissue we're talking about. So bone has blood vessels in it, okay? Cartilage, all right? We will learn, all right? In cartilage, it's going to be a little bit of a different. There's always exceptions to the rule, okay? And we'll get there. We'll talk about it more, okay? So when we talk about something that's very vascularized, areolar connective tissue is what we call a loose connective tissue. So if it's loose, that means there's lots of room for stuff, and blood vessels like to go where there's room. Okay? Then when we get to dense regular connective tissue, that's going to be ligaments and tendons. I have a lot of blood vessels there. That's why it takes them forever to heal. Okay? So they're poorly vascularized. Now, if you pay attention to this last one here, avascular, all right, mature cartilage. Okay? Baby cartilage, right, or immature cartilage, does have some blood vessels, but then as it matures, it loses those blood vessels. So you need to know that mature cartilage is avascular, okay? You guys at home seem quiet. Are you good? Okay, all righty. Good deal. I'll keep plugging along here. All right. So, as we go through, all right, this chapter and this section of the chapter talking about connective tissue, all right, we're going to see as I go through each type of connective tissue, we'll see all of these functions at work, and it'll make sense. It'll get to the point, like for these two here. All right, here. How about physical protection? From what we learned about our connective tissues already from lab, what offers physical protection? I already said it. Pardon? Yeah, skeletal. Yeah, skeleton. Remember our skull. All right, protects the brain. The vertebral column protects the spinal cord. Okay, so you'll start to see. All right, memorize the functions here, and then you'll start to see what applies to what. Support and structural framework. Again, we can use cartilage. All right, we can use dense regular connective tissue for ligaments and tendons. All right, binding of structures. Again, same thing. Dense irregular connective tissue. All right, we'll see in the skin helps. Storage, adipose tissue. Perfect. Okay, perfect. Transport, that's going to be more of the fluid connective tissue, blood and lymphatic, which we're not going to talk about in detail in this course. Okay. All right, and then immune protection. Okay, immune protection will be, again, all right, the fluid connective tissue is the first and foremost that comes to my mind, white blood cells. Okay, but we'll talk more about that in detail in chapter 211. All right, I always say that a lot. You're going to get tired of me saying that, but it gives you something to look forward to after this class. Okay, so here it is again, mesenchyme. All right, that is going to be, think of mesenchyme, all right, as you've heard of terms like stem cells. We're all pretty familiar with stem cells. Stem cells are all right, this cell line that can pretty much, not all of them, all right, certain ones can, certain ones can't, that can turn into almost any type of cell. All right, they're still experimenting and finding out. All right, you have the pluripotent stem cell, and that's the stem cell that can turn into almost anything. And then you have certain stem cells that can differentiate into maybe like 5 or 6 other types of cells that are similar. And we see that in our formed blood elements. All right, the white blood cells, the red blood cells, and whatnot. Okay. And then we briefly, mucus connective tissue, we only see this. This is one of the reasons why, all right, we've seen that they've been collecting more often umbilical cords and saving them for people in case later on down the road that you do need, you're limited for some stem cells, all right, if we ever discover the technology to actually regenerate tissue completely, like a new liver or something like that, okay? All right, I showed you this in lab. I strongly urge you, this is figure 5.9, all right, to memorize this. I don't ask you to memorize too much stuff in this class, but this one I will say that you should memorize, okay? Because when we're talking about, all right, connective tissue all together, all right, mesenchyme, all right, and then that mesenchyme tissue can differentiate into any of these 3. All right, the first category is connective tissue proper. The second one is supporting connective tissue, and the third is fluid connective tissue. Again, all right, you're not going to spend really any time on this. I'll identify it for you, but that's it. We'll go into much more detail in another class. Okay, so it's going to be these 2 here, all right, that we're going to spend more time on: connective tissue proper and supporting connective tissue. And how I always remembered supporting connective tissue, I just said, all right, cartilage and bone, that help to support the body, that's supporting connective tissue. All the other types of connective tissue, except for the fluid, fall under connective tissue proper. Because you're going to see some new terms in here, all right, like dense regular, dense irregular, elastic, all that stuff. That can be a little bit, you know, kind of confusing there. All right, so let's jump right in and get involved here. And let's talk about the first type of connective tissue, which is connective tissue proper. Connective tissue proper is broken down into loose connective tissue and dense connective tissue. Okay, so we're going to talk first about the loose. Okay, so one of the big characteristics of this type of connective tissue is that you want to know it's loose. All right, so that means we have very few cells, all right, and protein fibers. Okay, so we don't have a lot. Remember, 3 things make up connective tissue. Okay, I didn't write that on here, but I did. I went over it in lab with you. You have the cells, all right, and then you have the extracellular matrix, which is everything outside the cells. And we break down the extracellular matrix, or the EM, into protein fibers and ground substance. Okay, so that's what we're talking here. So this type of connective tissue has very few cells and protein fibers. So guess what? That means we have a lot of ground substance. Okay? And there's really, it's kind of an appearance on a slide, it looks disorganized. All right, the protein fibers aren't always laying down and going from left to right. They're just all over the place, like here and here and here. All right, they just go all over the place. And you'll have cells scattered throughout. Okay? So this type of connective tissue makes great packing material. Like when you get a package from Amazon or wherever. They used to use those small styrofoam beans, and then now I think they use like airbags or whatever. But regardless, that's the body's packing material. Right? It uses that loose connective tissue and it puts it in places. Okay? And so those 3 types are going to be areolar, adipose, and reticular. All right? You'll see the first 2 in a lot of places this semester, the areolar and the adipose. Okay? All right, so now let's talk about each individual type, all right, of loose connective tissue. Okay? The first one is the areolar. Again, not much organization, all right? Things are just all over the place. The protein fibers that we're going to see are going to be the collagen, which is the strongest All right, first type of protein fiber is collagen. Okay, and the next type, oops, number 2 is elastic. Does anyone remember what the third type of protein fiber is? That's right, reticular. And we also have, that's right, reticular. Good job, Brian. I spelled it wrong. Missed the I. Okay, so we have those 3 types. Know those, okay? In fact, we're going to talk about reticular, all right, tissue, okay? So collagen, elastic, and reticular. Collagen is the largest and strongest, okay? It does not branch. Elastic branches, reticular branches, okay? They're smaller, okay? So remember what I said about blood vessels and whatnot. They like to go to places that have a lot of space, okay? So areolar connective tissue is a loose connective tissue, all right? So there's a lot of ground substance, all right? So we have a high amount of vascularity going on. Blood vessels will start to just grow into those spaces there, okay? This type of ground substance, obviously there's a lot, but it's going to be a little bit more viscous, which means kind of thicker, not too soupy like syrup, all right, but more like motor oil. And we talked about the 2 different types of cells. There's wandering cells and resident cells. All right, resident cells, all right, are the ones that stay fixed in place. They don't move, okay? And then the wandering cells come and go, okay? They'll move in, they're temporary, all right? So we'll see all the different cell type varieties. So remember we talked about some of the white blood cells, the mast cells, neutrophils, lymphocytes. Those are white blood cells. Those are wandering cells. We have macrophages that are fixed macrophages, and then we have the wandering kind. All right. So we have a whole bunch. They all sit there. Fibroblasts is another one. So we're going to see this type of connective tissue in the top layer of the dermis. All right, the papillary layer, just underneath our epidermis, which is the epithelium. We'll also see, we haven't talked about this layer, the subcutaneous layer, the hypodermis. Remember, it's packing material. So we're going to see it around the organs. All right, we're going to see it around blood vessels, nerves, all right, within the heart. All right, anything that, if it's affiliated with the any blood vessels, we're going to find it in the heart also. Okay, so it's everywhere. All right, that's areolar connective tissue. All right, the next one is adipose. We've seen this one before, fat. The predominant cell type is going to be the adipocytes. All right, there's 2 types in our body. All right, you have white and brown. Brown is in abundance when we're young, when we're babies. Okay, helps keep us warm, generates heat for us. All right, but as we get older and grow, it diminishes. You still have some. All right, mainly around your shoulder blades, underneath your shoulder blades, but that's pretty much the predominant area there. White is the one that we're more familiar with. All right, and then unfortunately, as we get older, sometimes we accumulate more than what we wanted. All right, but this is the one that pretty much exhibits the functions and the characteristics of fat. All right, stores lipids, and that's that stored form of energy. So it's an energy storage facility, and you'll find it around certain organs. That's why people that have lost a considerable amount of weight, anorexia nervosa is an eating disorder, and those people are grossly underweight, and they have reduced their overall total body fat content, that it can cause damage to their internal organs because even that fat is gone. I mean, that's an extreme case. So, and we want some fat around our internal organs, because as we're walking around, our organs aren't always just fixed in place. I mean, for the most part they are, but there's a little bit of movement there. But if they're, especially if you're running, they get jostled around, they're smacking into each other, and that can cause damage, okay? So we want to keep, all right, adipose tissue at the proper amounts, all right, because it acts as a cushion, and it also obviously keeps us warm in the wintertime, all right? All right, then finally the last type of loose connective tissue is reticular. I want you to think of reticular connective tissue, all right? This is going to be associated, think of it like scaffolding. I went to New York City 8 years ago when it was still happening, when the stuff was going on, and St. Patrick's Cathedral takes up a whole city block. This place is huge, big church building and then office buildings. They had that thing completely encased in scaffolding inside and out. It was undergoing, get this, wait for it, $110 million renovation. Yeah, that's what I'm saying. $110 million, all right, to renovate this place from top to bottom, inside and out. Well, anyways, it's filled with that scaffolding. But I think we've all seen scaffolding. All right, there's a building that's under construction out here when you walk out the back door off to the left of the back side of the building there. So they have kind of like the not scaffolding, but the skeleton of the building put up. All right, so think of reticular fiber, well, reticular connective tissue. One, it's mainly made up of reticular fibers. These reticular fibers, if you look over here, all right, it makes up, all right, these little compartments in here. All right, obviously the white is the ground substance, that's a lot of space. All right, but it has all these little compartments here. Okay, and so you'll see mainly, all right, our leukocytes in this type of tissue, our white blood cells. All right, you'll see this type of tissue, all right, in, all right, your lymphatic system, which includes, remember, your lymph nodes. If you ever notice, if you're sick, you have some tenderness around your neck and head and everything, people are like, oh, I've got swollen lymph nodes. All right, that's because a lot of white blood cells have migrated into that area there. All right, because part of the immune process is kind of displaying whatever it is that's infected you to other white blood cells to initiate the immune process. Okay, so we'll see this type of tissue, all right, in our lymphatic organs, so spleen, thymus, the lymph nodes, obviously, and then we'll also see it in where our bone marrow is located on in the medullary portion of a lot of our bones, right, when we are starting to produce the foreign blood elements, all right, which are white blood cells, red blood cells. All right, so I just tell folks, think of this type of material, all right, like I think I described it to you last time as a storage, like those easy U-Haul or easy storage facilities, all these little compartments all over the place where we're going to keep things, because the majority of your white blood cells, it's not in your blood. A lot of people assume that. It's not. It's in your tissues. All right? They're constantly controlling your body as we speak, as we're sitting here. And they're checking you over, making sure that whatever cells they come in contact with belong there. Because if they don't, they're going after them. All right? So they're out there in the tissue right now. As you sleep, they're doing their work. All right. The last type, not the last type, but the next type of connective tissue proper, all right? You have the loose connective tissue. Now we have the dense connective tissue, okay? So with dense connective tissue, it's a little bit different type of organization there, right? You don't have much ground substance. If you don't have a lot of ground substance, that means you don't have a lot of empty space, like parking lots, like a parking lot with all spaces taken up, all right? You can't park your car there, all right? Well, the blood vessels can't, if there's not a lot of ground substance in space, you won't have a lot of blood vessels to move into those areas there, all right? So we'll see, all right, the ground substance is going to be substantially less, okay? And you'll have protein fibers, but mainly the collagen protein fibers. So this type of tissue won't be, well, it varies on its vascularity, let's just say that. It won't be as vascularized as loose connective tissue, okay? But it varies, all right? So keep in mind, less ground substance, more protein fibers, predominantly or especially collagen, okay? So there's three types: dense regular, dense irregular, and elastic. All right, let's hit the first one, dense regular. All right, this is the one we talk about in lab. It's got the lasagna noodles going on. So what we've done is we've taken all these collagen fibers and we laid them down parallel. So if we go down here to our picture here, you can see, all right, all this pink stuff, those are the collagen fibers just laid down nice, uniformly, right on top of each other. Very little white here is actually the ground substance. So there's very little ground substance here. And then you can see the fibroblast, or at least the nucleus of the fibroblast here. Fibroblasts make collagen, okay? So, and you don't see in that particular sample a blood vessel, okay? Not to say that there isn't a blood vessel somewhere in this tissue, it's just not on the slide, okay? So we're going to see this type of connective tissue in ligaments and tendons, okay? So since it has a low blood supply, it takes a long time to heal when it gets injured. Anybody know anybody that's ever injured their Achilles tendon? That's the big tendon down there. It takes a long time, depending on how badly injured it is. All right, it can take anywhere between a year up to 2 years if it's completely. I mean, it takes a long time. Okay. Next type of dense connective tissue is dense irregular connective tissue. Okay. Now this one here, again, the predominant protein type is going to be, all right, collagen, except instead of it being laid down nice and evenly and parallel and uniformly, this collagen, it's clumped together, okay, which is good and bad, okay. It's good because it gives a little bit more room for ground substance. So this type of connective tissue will have a little bit more vascularity than dense regular connective tissue, okay. And it also, all right, provides, all right, how do I want to say this, multi-directional stressors, okay? So for example, if your skin, all right, the dermis, the bottom layer of the dermis, okay, the reticular layer has tons of dense irregular connective tissue. So that's good because I can move my skin and pull it in different directions, all right, and it won't become damaged, all right? And that's ideal. Whereas if it were just dense irregular connective tissue, it would be really strong in one direction, but if you pulled it just as hard in a different direction, you could damage it, okay? So this is great because it can handle stress in multiple directions there, all right? So again, we're going to see in the lower layer of the dermis there, all right, periosteum, which is the covering to our bones, and perichondrium, which is the covering to our cartilage. And pretty much, remember I was saying, all right, if you see a tissue or an organ that has a fibrous capsule around it, all right, when they use the term fibrous, that's usually an indication that that is dense irregular connective tissue, okay? So your kidney has a fibrous capsule around it. Actually, your perichondrium, okay, your pericardium, which is the sac that holds your heart, the outer layer, they call it the fibrous pericardium, that is dense irregular connective tissue. Okay, so it can handle multiple multi-directional stressors. All right, and the last type of elastic connective tissue, the last type of dense connective tissue is elastic. All right, and so hence, you can figure it out from the name. All right, the predominant protein fiber is going to be elastic. Okay, now again, elastic and reticular protein fibers can branch. All right, so these elastic protein fibers will branch, all right, which allows it to undergo stretching and recoiling, much like the elastic waistband in your underwear, your athletic shorts, or sweatpants, or whatever. All right, so it can stretch and recoil, which is wonderful because we're going to see, all right, this type of connective tissue in our larger arteries, which is good because if you start to exercise, right, what happens? Your heart starts to beat faster, right? Your blood pressure is going to increase because more blood is going to be being pushed out. So this elastic connective tissue in those structures will help compensate for that increased blood volume and that increased blood pressure so we don't burst blood vessels, all right? Trachea is wonderful, and our vocal cords. I'm exercising mine quite a bit right now. So you can see on this slide here, all right, all these dark staining lines here. That's pretty much anything that's dark or purple on here. It looks purple to me. All right, that is going to be your elastic protein fibers. Okay. Again, we don't have a lot, and the white is going to be the ground substance. We don't have a lot. All right, but definitely we got more than the dense regular connective tissue. All right, questions so far on that? That was the first type of connective tissue proper. All right. The other stuff is not as hard. Because we're already familiar with cartilage and bone a little bit, you know. All right, so the next major category for connective tissue, all right, is our supporting connective tissue. All right, and we have two types here. You've got cartilage and bone. And in cartilage, there's 3 subtypes. We'll go through those. And for bone, there's 2. All right, so let's start off with the cartilage here. All right, cartilage is not going to be as rigid as bone. All right, so we consider it to be firm, but we also classify it as a semi-solid, which means it's solid, but it's like bendy. All right, it can actually handle a little bit of stress, and it can bend a little bit with it. Okay, you have high amounts of collagen and elastic. Hence, all right, both of those protein fibers will confer the semi-solid, all right, description, allowing cartilage to be a little bit more, quote unquote, bendy. Okay, so the predominant cell type in cartilage is what we call a chondrocyte. All right, that's the mature cartilage cell. Okay, and they live in a space, a chamber, what have you, that's called the lacuna. And if you've taken the lab exam, you may have seen that on one of the lab slides. Okay, asking you to name the space of whatever cell. All right. All right. So what we're going to see when we're talking about cartilage, that similar to bone, okay, cartilage has a covering to it. Okay, 2 out of the 3 cartilage types have a covering. All right, that covering is called the perichondrium, and it's made up of that dense, irregular connective tissue. Okay, and we'll get into it in a little bit more detail when we get into chapter 7, which is the skeleton, and we talk about cartilage and bones in more detail. Okay, but that perichondrium has 2 layers to it: the outer fibrous layer, which is then it's made up of that dense, irregular connective tissue. And then there's a single layer on the inside of the perichondrium, and that's what we call the intercellular layer. And that's where we're going to get our baby cartilage cells, chondroblasts. Okay? More on that when we get into chapter 7. Okay? But for right now, just want you to know that the mature cartilage cell, all right, is the chondrocyte. The space that it lives in is a lacuna. And then when we're looking at cartilage, it's covered by perichondrium. It has 2 layers. The outer layer is called the outer fibrous layer, which is made up of dense, irregular connective tissue. And there's a layer on the inside of it. It's 1 cell layer thick. All right, that's the inner cell layer, and that's where we're going to have our baby cells, our chondroblasts. Okay, but we'll talk about that more in detail. Okay, so a couple characteristics of cartilage. Okay, all right. It is going to be a very, very firm, all right, type of connective tissue, and it's strong, all right? So it's going to be more resilient than the other types of connective tissue that we've talked about so far. But it's not going to be as rigid as bone, so it has more flexibility. And that's because of its collagen and elastic fiber makeup, and it has a higher content of water, okay? So when it's mature, and this is a great test question because I've asked it on mine. All right, when it is mature, it is avascular. Okay, so it's talking about avascularity for cartilage. You better make sure that it mentions that it is mature. Okay, so there's 3 types that we have. We have hyaline. All right, that's the most abundant. That's the most common. Fibrocartilage, which is one of my favorites. The fibrocartilage, all right, does not have a perichondrium. Okay? I'm not going to spell it out, but all right, does not have a perichondrium. Okay? And then we have elastic cartilage. So cartilage 1 and cartilage 3, they have a perichondrium. They got a nice covering to them. Fibrocartilage does not. It's too tough. It doesn't need it. Okay? All right. So let's talk about each type. All right? And we'll go into a little bit more detail about hyaline cartilage in chapter 7. Okay? So I'm just going to give you the basics here. And this is the one that's most common. All right? It has a perichondrium. All right? And we're going to see this all throughout our body, and especially during the beginning portions of our life, all right? Because, all right, a majority of the fetal skeleton, as you're developing inside your mom and you're starting to take on that human-like appearance, all right, majority of those bones, all right, before they become actually bone, are cartilage, okay? On the ends of our long bones, all right, like in our knee, our elbow, our knuckles, all right, we have hyaline cartilage on the ends of the bone, okay? We call it something different. We call it articular cartilage at that point, but it's hyaline cartilage. And it acts to help, 1, protect the bones as they're rubbing against each other, okay? Because bones are very sensitive, believe it or not. They're tough, but they're sensitive, all right? And it helps to act as a shock absorber. All right, we'll get into more detail about that. All right, costal cartilage. Does anyone know what that is? Ribs, that's right, costal being rib, that's right. So the ends of your ribs, as they come towards the sternum in the front, all right, they're going to transition and form a joint. The bone, the actual rib bone, will form a joint with the costal cartilage, okay? And then the nose, the tip of your nose, okay, that is also hyaline cartilage, all right? All right. The next type is the fibrocartilage. This one here, it literally carries a heavy load. It's a weight-bearing type of cartilage because after I tell you where it's located, you'll agree with me, you know, why it's a weight-bearing type of cartilage. So it's undergoing compression all the time. It's getting, to use a southern term, it's getting mashed down, all right? All the time, getting mashed, all right? So this type of cartilage, we will see tons of protein fibers, mainly collagen, okay? And we'll see in these protein fibers, all right, and it's you can't really appreciate it on this slide, but the one in your atlas you can appreciate it a little bit more. All right, you'll see the chondrocytes are almost lined up in a row in some of them. All right, we refer to those as the bundles. All right, but for whatever reason, they just get moved into that position there. All right, here's a huge thing that you need to know. I mentioned it before. No perichondrium. Okay, and hardly any ground substance. Hardly any. So this type of cartilage is located in 3 places. In between the vertebrae, your discs, your intervertebral discs, are made up of this cartilage. So they act as a shock absorber for your spine. Okay. Also, you'll see it in your knees. You've heard of the menisci, all right? Some people have torn their menisci, or some people have damaged them heavily, all right? But literally, those act also as shock absorbers. And then finally, where your 2 hip bones come together in front, right underneath your belly button, about 2 inches below your belly button. You have a little disc there, all right? And they call that the pubic symphysis, right? And that's where your 2 hip bones come into place, because when your hips undergo certain forces, all right, they'll press against one another in the front. So you have a disc there to absorb some of those forces, okay? All right, questions so far? All right, the last type of cartilage, all right, is our elastic cartilage. And hence, elastic should tell you, all right, like an elastic waistband in your athletic shorts, it's going to be springy. So this type of cartilage, all right, you're going to see that it's going to have a high content, more so a higher content of the elastic fibers, okay? So elastic is going to stretch and recoil nicely. So we're going to see with this type of cartilage, all right, in structures in our bodies that will stretch and recoil nicely. One of them is the epiglottis, okay? And if you're not sure what that is, that's this flap that sits over, it's called the glottis, and the glottis is a hole, all right? And that is the opening to your trachea. So when you swallow liquids or eat food, they'll push against the epiglottis and it'll push it down over the glottis. So it essentially closes off your windpipe. I hate to use that word. It closes off your trachea. So nothing goes down in there because that's bad. All right. And then when you're done doing whatever, it springs back open. Okay. And then the external ear, this guy right here. So if you pull it down, it springs right back into place. That's external. All right. The external ear there, that's made up of elastic cartilage. All right. So one last part, I didn't mention that the chondrocytes in this, all right, it's not drawing. No, it crashed. You guys, can you hear me at home? They're going to type yes. What line am I on? 49? Okay. I just hope that it's not the server again. Sorry, y'all. Give me 1 second. You know, I've thought about using my own laptop computer because it does have a webcam on it, but I can't get it hooked up to those things. I don't have the thing for that. they can't hear me. No, what? All right, let me try again. Can you folks hear me at home? All right, sorry, I don't know what happened there. It crashed on me. Okay, good. All right. All right, so let's move on to bone. All right, we're almost done with connective tissue. Okay, bone, the other part of our supporting connective tissue. All right, from what we know that bone is less flexible. Okay, bends less, but it can bend slightly, which is good. Because sometimes bone needs a little bit of flexibility, a tiny bit, because if it wasn't flexible at all, we'd be breaking our bones much more often. So it's good to have, right? But it is stronger than cartilage, so it will offer more support, okay? All right, so we'll talk more about it in chapter 7, and I really enjoy talking about it. But for right now, you have to understand that bone is made up of two components, an organic component and an inorganic component. Now, before I ever took an anatomy course, I said, oh yeah, it makes sense. Bone is inorganic. You know, it's hard, you know, all right, like a rock. So that's easy, okay? But the organic component, you need the organic component, all right, if you're going to have the inorganic component, okay? So the organic component is mainly made up of collagen, all right? And there's that word again, glycoproteins, protein with a carbohydrate group attached to it. All right, that's hugely important for when we're making bone. All right, and then our inorganic component is going to be what gives bone its hardness, its resiliency. All right, and there's several different terms. All right, the book likes to call it calcium salts. I've referred to it as bone salts in some of the literature I've read. It's technically called hydroxyapatite, but again, we'll talk about that more in chapter 7. So the predominant type of bone cell, all right, or the mature cell is going to be the osteocyte. So similar to the chondrocyte, it lives in these little lacuna, which are these little spaces or chambers throughout the bone, okay, or what we call the extracellular matrix. All right, and the extracellular matrix is made up of organic and inorganic components there. Because it's the osteocyte, not so much, but the osteoblasts, all right, they make the bone. Okay, so they secrete the organic matrix, and then calcium comes in and it makes it hard, and then these cells live in the bone, all right? And the cells that live in the bone are these guys, the osteocytes, okay? So there's two types, compact bone and spongy bone. All right, we saw the compact bone in lab. We didn't really see the spongy bone, okay? So the compact bone, all right, are going to have these structures inside of them called osteons. And they're a circular-like structure, all right, similar to the trees of a, the rings of a tree, okay? So have you ever seen a tree cut down? You know, you have these rings that are growing around the center of the tree. So it's very similar to that, all right? And those rings, all right, we call them lamellae. So these rings are pretty much the connective tissue, all right, of the bone. Right? And at the center of it, you have this hollow canal. Does anyone know what the name of that is? That's right. Did anyone have that on their test? Have they taken the test? Did you have it? Did you know it? All right, good. Yes. All right, because I get nervous because sometimes people put nucleus down, and because they think that's the cell that they're looking at, and I could see why, and I always mention that in the semester, like, don't write nucleus. And sometimes I'm like, well, should I say that? Because now I'm putting the thought in their head, and I'm afraid that someone's going to write that down. So it's the catch-22. But anyways, at the center of our osteon is our central canal, and it's a hollow tube. And what lives in there are our blood vessels, right, and nerves. Now the nerves that are primarily in bone are sensory nerves. All right, there's no need to have motor nerves inside of a bone because bone doesn't contract like muscle does. Okay, so it's mainly sensory nerves. Okay, and they're at the center of all of these osteons. The other type of bone is spongy bone. Okay, this is going to be found internal to the compact bone. Okay, so the compact bone is going to be more around the superficial surface, or the superficial region of the bone, and then a little bit deeper inside is going to be the spongy bone. All right, and the spongy bone is like the scaffolding or the lattice work. And I'll show you a picture. All right, this is where you're going to find your bone marrow. Okay, it lives on the inside in the spongy bone. All right, it's going to be fine. The spongy bone is similar to reticular connective tissue because it, you know how the reticular connective tissue made these little compartments. Spongy bone does something similar to that. Okay, all right, so it's going to be more towards the interior of our bone. All right, where we'll see the compact bone more towards the exterior. Okay, so we'll go over this more in detail in chapter 7. But some of the functions of bone, all right, levers for movement. Okay, helps to support some of our tissues, like our muscle tissue attaches to the the bones. All right, so it actually helps for support. All right, what do our ribs do? They help protect our lungs and our heart. All right, so it helps with protection. Our hips help to protect some of the internal organs in your pelvis there. All right, big storage site for calcium, phosphorus, magnesium. Tons of that is stored in our bones. And you're going to find out, you're going to have a whole new appreciation of calcium. When I was growing up, I was told calcium helps you build strong teeth and bones. So much more than that. All right, it helps with muscle contraction, helps with neurological function. All right, for nerves to actually work, we need calcium. All right, it helps with blood clotting. Okay, so tons of stuff. All right, so also within our bone, it gives a home to what we call our hemopoietic cells. And hemopoiesis is the process of creating the blood-formed elements of our blood. Okay, which is red blood cells, white blood cells, and platelets. All right, so all that, all right, all those cells are made in the bone. Okay, through the process of hemopoiesis. Okay, and you get to learn about that later, not this semester. All right, can you guys still hear me at home? Only one person answered yes. You guys decide. Just kidding. Okay. Yeah. All right, you're good. All right, I just want to make sure this thing it acts funky. All right, so here you can see, all right, our compact bone. This should look similar to what you saw in your atlas here. Here's your central canal, and then you have these rings going around the central canal. These little dark dots here around the central canal, those are the lacuna. Okay, and the lacuna are the spaces or the chambers, all right, where your osteocytes live. And they just hang out there, right? And they maintain the bone matrix, okay? So if the bone matrix is damaged somehow, all right, say you've been working out at the gym and you gain 50 pounds of muscle, all right, and you need to strengthen your bones, all right, that will stimulate, all right, those osteocytes, all right, and stimulate the functions of some other bone cells that we're going to learn about to start to make more bone, okay? So they just hang out there. It's like has anyone ever heard, well, I'm sure some of you, I don't always expect all of you, have heard of Edgar Allan Poe. He was a short story writer in the 1800s, I believe, late 18th century. And he wrote this story called The Cask of Amontillado. It's a pretty cool short story. It's a story of revenge, go figure. And this guy was planning on getting revenge on this other guy, and I cannot remember what for. So he gets him drunk, not drunk, he gives him something to drink, drugs him, and the guy passes out. This is in Paris, I believe. And he drags him down into the catacombs under Paris. Are you familiar with the story?
I literally just put my brother in the paper like 2 days ago.
On the castle, oh yeah, yeah.
I watched the whole thing.
Oh yeah, it's cool. It's just a crazy story because, well, anyways, so the guy comes to, and he's paralyzed. And the guy that wants revenge on him is slowly sealing him into the catacombs. And he can't move. And he's putting brick by brick with like the old mortar and everything. And as he's doing this, he's telling him the reason why am I right on that? All right, it's been a while. It's been a long time. And he's telling him why he's seeking revenge on him. And he has one last brick there. And the guy screams out, "For the love of God, Montreseau." And the guy says, that's the bad guy. He says, "Yes, for the love of God," and put the last brick in there and seals them off in there. Well, that reminds me of what osteocytes do to themselves, right? They're what we call an osteoblast, and they build bone. And then when it's time to stop building bone, they just stop. And now they're stuck. in the middle of all this bone matrix, and they can't go anywhere. So they've literally sealed themselves in there. It's like a painter that paints himself into the corner, you know, and he can't get out. Well, that's what osteoblasts do, and then they just convert into an osteocyte, and they're like, well, I'll make the best of a bad situation. I'll just support the bone matrix around me, and that's what they do. That's a long explanation. All right, the last type of connective tissue here is the fluid connective tissue. All right, so we have connective tissue proper, supporting connective tissue, and fluid connective tissue. And fluid connective tissue is made up of, all right, blood and lymph, the two fluids in our body, okay, that circulate around, okay? So when we talk about the blood, all right, that's our formed blood elements, which include, all right, all those cells I just mentioned, red blood cells, erythrocytes, white blood cells, leukocytes, and then all the subclasses there, and platelets, okay? And so our red blood cells, they're going to move carbon dioxide and oxygen throughout our body. The white blood cells and leukocytes are going to help keep us healthy and fight off infectious agents. All right, and then platelets are going to help to clot the blood. So those are our formed elements of our blood, okay? Well, our blood's liquid, okay? And that liquid is what we call plasma, which is our ground substance, okay? The majority of our plasma, 92% of it is water, all right? And actually, I did the math. Plasma makes up about 55%, no, I take that back, 54%, no, 55% of your actual blood. So if you multiply 55%, or no, divide 55% by 92%, the overall half of your blood volume is water, okay? Literally half. It's like 50.4%, right? Point being is that's the majority of your plasma. About 7% are dissolved proteins. And then the other 1%, all right, is hormones, all right, like urea, ammonium, that kind of thing, the waste from cells, all right, and some other nutrients like glucose, okay, and whatever else is not attached to a transport protein in your blood, all right? And I joke around, and I used to call lymph the sewage system of your body. It's not really, okay? It's basically your blood plasma that got filtered out. So it has no cellular components or even parts of cells, okay? But it gets filtered out because your body loves to recycle stuff, right? If you sprained your ankle, it gets swollen up, all right? You have all these cells that were in there fixing that area, all right? And then we have to clean them all up, and then it takes it through the lymphatic system, and it gets filtered by some of your lymphatic not vessels, but organs like the spleen, okay, and the lymph nodes. And we drop off some cells here and there because we'll use them later on, and then it drains itself back into the blood, only to be then circulated throughout your body. It goes to the kidneys, and that stuff gets filtered out. So it's a really cool kind of system here and how things work. All right, here's the blood. Okay, so this is the blood smear here that we've seen. You can see obviously the red blood cells. Those are the majority of the cell that we see. They're biconcave like a donut, all right, except it doesn't have the center missing. And then these bigger cells over here, these are going to be your leukocytes, all right, your white blood cells. This one's a multi-lobe, this is the nucleus, believe it or not. All this dark stuff here, and it's what we call a multi-lobe nucleus, all right, and that's the neutrophil, okay? That's the most abundant type of leukocyte or white blood cell. Then over here we have a lymphocyte. It's another type of leukocyte or white blood cell. And then if you look, well, it's tough to see. There we go. And you can see these little dots here. Those are the platelets. All right. There's only one real good one here. All right. That should be it. All right. For I'm going to start on the third type of tissue. All right. Muscle. Okay. There's three types. Okay. So first of all, when you see the word muscle, your brain should automatically defer to this word right here, movement. M muscle, M movement. Okay? Always, 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 always. Because that's what muscles do. They move. They move. They'll either move things or they'll cause other things to move. All right? So these cells, and we'll learn about all the characteristics when we do chapter 10. All right? But when they are called into play to do something, they will contract, which is get shorter. Okay? And when that occurs, it creates that movement that we want. Now, there's different types of contractions. There's voluntary contractions, and that's what our skeletal muscle does. All of you If you're taking notes or moving around, you are engaging voluntary contraction of your skeletal muscles, okay? So that's the first type of muscle tissue here, the skeletal, that's voluntary. The other two, cardiac and smooth, are involuntary. You cannot control, all right, when they contract, okay? You cannot. So, cardiac, all right, it's only found in one place, in the heart, specifically the middle layer of the heart wall, all right, which is called the myocardium, all right? And what is its job? To move blood, pumps the blood. The other one, smooth muscle, that's another involuntary one, okay? It's located all over the place. You'll find it in the respiratory system. You'll find it, all right, in the digestive system, all right? You'll even find it in the skin, all right, the erector pili muscle, okay? So it's also involuntary, but it also is going to cause things to move, all right? We're talking about the digestive system. It's going to move food, all right, from the origin of where the food came in, all right, in the stomach, and move it out towards the anus, okay? So those are the three types of muscle tissue. So always be careful about how things are worded, all right? If you're asked, like I usually do, what are the four tissue types of the body? That's epithelial, connective, muscle, and then nervous tissue, okay? Skeletal muscle, cardiac muscle, and smooth muscles are one type of muscle tissue, okay? So we'll dedicate a whole chapter to pretty much talking about skeletal muscle tissue. We're just going to talk about it briefly here, all right? So, but these are some really important facts that you should know about this tissue here, all right? Skeletal muscle is striated or striped, which means it has alternating light and dark regions, okay? And it's the only type of voluntary muscle tissue. The other two are involuntary. So we all can figure out what it does. It's going to move the skeletal system, the bones, okay? So it's going to create movement within our skeleton. All right, so these cells, and we'll talk about it in much more detail, they're long. We saw, well, what am I saying? We already talked about it in lab. Long and cylindrical, and they're multinucleated. Okay, because at one point, you had these baby muscle cells called myoblasts, all right? And when we were developing, they all fused together, okay? And when they fused together, none of them wanted to give up their own nuclei, so they kept their nuclei. It formed one big cell. And so you have this type of muscle tissue will have many, or what we call multinucleated, okay? Important to know. Okay, alternating light and dark, we talked about that, and it's voluntary. Oh, this is something you should know. Does not contract unless stimulated by the somatic nervous system. The somatic nervous system is the nervous system that you have conscious control over. So when you smell something, when you touch something and you realize it, that is part of your somatic nervous system, the sensory part of it. The motor part of it is this, skeletal muscle, okay? So you have conscious perception of some of your senses. That's part of the somatic nervous system. When you have conscious or voluntary control of movement, all right, that is also the somatic nervous system, specifically the motor component to it. We'll learn about that. We'll learn about that. All right. Here you can see, I think the picture in your book, in your atlas is better than this, but here you can see, okay, alternating light and dark, multinucleated, okay, no branching. None. Only place where you'll find this type of tissue is in your skeletal muscles and nowhere else. Okay? Skeletal muscles. All right. The next muscle, I'm going to finish up with muscles and then we'll call it we'll take a break. Okay? Cardiac muscle. Okay? This is an involuntary muscle found in the myocardium, okay? It's also striated, and I tell folks, I describe it as a Y laying on its side. It branches, okay? And it doesn't, it can have more than one nuclei. It can have 1 to 2, but it doesn't have as many as skeletal muscle has, okay? and its job is to move blood. Just pump and move blood. And we have these structures called intercalated discs, and I talked about them before, all right? And there's two things that make up the intercalated disc. They're called desmosomes and gap junctions. The desmosomes are basically the cell's ability to sew itself to another cell. So it's an attachment site, okay? And what that does is that helps to strengthen, all right, the connection between the cells, so when the cells are contracting, you get a much more effective and a much more worthwhile contraction when we're pumping the blood, okay? And then the gap junctions are literally these holes in between the cells. And so they allow for the electrical current that washes over the cardiac cells, all right, to move with much more ease, okay? And it allows, because if you think about it, the heart can beat, you know, I mean, the average heartbeat is anywhere between 60 to 100 beats per minute. But if you're doing something that requires exercise, you can get up to like 140 beats, sometimes 160. If it's over 200, that's bad. All right, that's bad. Okay. But point being is, all right, every time, and we'll talk about this, when a heart has to beat, it has to what we call depolarize and repolarize. All right. So that needs to happen fast. Those gap junctions help with that. And then of course it's involuntary. And so it is not controlled by the voluntary nervous system. So it is not controlled by the somatic nervous system. It's controlled by what we call the autonomic nervous system. We'll talk about that later on. And then we have a special cell inside of this tissue. It's called the pacemaker cell. It's not the pacemaker, all right, which is the SA node, okay, the sinoatrial node. That's different, all right, but you have these special cells. All right, they're called pacemaker cells, all right, which help with, that's why if I were to, has anyone here ever seen Indiana Jones and the Temple of Doom? You know, like the bad guy, the priest, he'd rip in and pull people's hearts out and they'd still be beating, okay? That's because of these pacemaker cells. They'll allow the heart, for a short period of time, all right, for the heart to beat. So there is some truth to that, all right? The heart can beat for a little while outside the body. If any of you have ever heard that, it's true. All right, so here is our cardiac muscle tissue here. Okay, so you can, it's not the best. I like the one in your book, is way better. You have striations here. All right, we have a couple nuclei per cell, and there is some bifurcation here. Again, it's not the best, but these dark lines here, those are the intercalated discs. Okay, so they'll help with the conduction and the actual effectiveness of the contraction. All right, last slide. Smooth muscle. Well, two more slides, this one and then the picture slide for it, okay? Smooth muscle is the last type of muscle tissue, okay? All right, it is involuntary. We also refer to it as visceral muscle tissue because we find a lot of smooth muscle in the viscera, okay? Throughout our digestive system, throughout our respiratory system, all right? Throughout, the circulatory system, your blood vessels, okay? So, hence another name for it. It doesn't get called that too often. It's usually just smooth muscle. All right, so we call it smooth muscle because, hello, there's no striation. All right, we don't have that. So these guys look like, I say a football. The book describes it as a spindle shape. All right, that's actually not too bad. All right, and it almost, when it contracts, it looks like if you've had to wring out a towel, that's kind of how it contracts. It kind of twists a little bit, okay? So it only has one nuclei, all right? And again, look at the list of things that you find it in the walls of the intestines, small and large, stomach, airways, bladder, uterus, blood vessels, it's all over the place. So its job is to move things through these organs. And again, it is involuntary. You do not control it, okay? You can't stop food from moving through your small intestine, okay? All right, and finally, the last one right here. Here's a picture of the cells here, all right? So they kind of look, again, all right, when they contract, they kind of twist on themselves. But you don't see, all right, any striations here in the cells themselves of the tissue. All right, Any questions for me from anybody at home or anybody here? We hit a lot. I promise you, I will wrap up this chapter in that video, all right, and I'll get that out to you. I'm afraid that if I stop recording, that it'll crash again. So if you lose contact with me, people at home, meet us in the lab class. We'll take about a 15-minute break and we'll meet in lab class. And if you have any questions at home, ask it in the lab class. Okay? I'm going to try to stop recording here and see if we have